1. Hi students, our study today is about the inverse function. What is an inverse function? Suppose we have a function f from x to y, where x is called the domain and y is big X called the domain and big Y is the range, such that y equal f of x. Given that f of x is 1 to 1 and onto, it means I mean here by monotonic increasing or decreasing. Then if you have x, you can go to y under a function f. And if you want to return back from y to x, you return back under a new function. This function is called by f inverse of y. X to y, you write y equal f of x. Y to x, you write x equal f inverse of y. And this is a function y because we said that this function is 1 to 1 and onto. So in this case, because it's 1 to 1 and onto, if you have here a mapping from this number, from this point to that point, or this point to that point, if you go from 1 till 5 under f, under function here f, you go from 5 to 1 under function is called f inverse of y. In that case, in function f, this is the domain and this is the range. In function f inverse, this is the range and this will be the domains. So it will be just the opposite. So if you have a point whose coordinates, for example, x, y, for example here 1 5, in f inverse it will be yx. So you replace here in that case to find the inverse x by y, and you replace y by x. And to find the inverse, you need that the function to be 1 to 1 and onto. It must be bijection, monotonic increasing or decreasing. Let us go to graphical representation of function f and its inverse. We said that if you have a belong to ab to function f, then the inverse you permute b to a and a to b. X will be y as we said and y to be x. And since the only function where if you replace x by y and y by x is the line y equal to x, so f and f inverse are always symmetric with respect to y equal to x. So let us see it using Geogebra. So f and f inverse of x are always symmetric with respect to y equal to x. And we're going to see it clearly when you're going to use the Geogebra now. So here, let me graph first of all y equal to x, the line, the middle one. Let me take any function, for example, y equal to x minus 3. So this is a function. Now what do I want? What I want to do? I want to replace y by x and x by y because domain will be range and range will be domain. So you're going to get 2y minus 3. X equal to y minus 3. So here, and if you pick now any point here on this function and you do the symmetry with respect to a line, with respect to y equal to x, you're going to get a point opposite to it. And if you join it by segment, and if you want to find, for example, more distance between point A and line, the line here is f, y equal to x, and the distance from point A prime and line f, as we said, you're going to see this distance is the same. Okay, and if you want to do animation, you can see that this function f is symmetric with respect to this one with respect to y to equal to x. Okay, let me take another function. Let me change it to another one. For example, if you want to take, for example, x cube, you can see also you're going to get the same thing. And if you want to replace here in this one, here we have up here. we're going to replace x equal y cube. You replace x by y and y by x. You're going to see also both are symmetric with respect to the line y equal to x, as you can see, and you have the same distances between the two. So always f and f inverse. So if you want to graph it, you have a function, you pick points, you draw y equal to x, you do perpendicular same sign, perpendicular same sign, then you can you can graph the f and f inverse, the function and its inverse. So steps to follow to find inverse function. First of all, we must check that the function is monotonic. It means one-to-one and onto by proving that if f of a equal f of b, then a is b. What does this mean? It means if you have, for example, here, suppose you have a and b. If f of a equals, suppose a and b are different for first. They say, the proof said to be one-to-one, if f of a, suppose f of a equal f of b equal to the same point. If you have this case, so if f of a equal to f of b, 100% a and b must be 1. So a and b must be coincide. So that in that case, what do we get? It is one-to-one and onto. So in that case, the function is monotonic. It means strictly increasing or strictly decreasing, either going always up, as we said before in another video. Monotonic is strictly increasing or strictly decreasing. In that case, the inverse exists. Second step, we replace x by y and then y by x. We solve again for y. Then we're going to find the domain of inverse function if needed. We're going to see an application. So we're going to return back later to these at the end. So now, application problem, find inverse of x, then indicate its domain when required. So I want to find the inverse of this one. First of all, here it's a line, and we know that the line is either always increasing or decreasing, so it's always monotonic. It's one-to-one and onto. So, but if you want to prove it, we say suppose f of a equal f of b. F of a is minus 3a minus 5. F of b is minus 3 minus 3b minus 5. So here you have minus 3a equal minus 3b, so a equal to b. So the inverse is a function. Second step, we replace x by y. Y by x and x by y, and we solve again for y. Solving for y, we put y on one side and we take x to the other side with the number. So the inverse function will be x minus into x plus 5 over 3. Let us check something. Suppose I want to find f composite of f inverse, for example, of 1. You must get 100% must be 1. That's what here I was saying in this one. I told you later. So let us take it by example. F inverse. So f row f inverse of x is x. So f row f inverse of y is y. So let us see it here. If you do f inverse of y, 5 plus 1, 6. 6 over 3 is 2. So you have f of minus 2. And if you go and put here f of minus 2, so 6 minus 5 is 1. So because you go from, for example, f inverse of y, you go from 1, as we said, to minus 2, then we return back from minus 2 till 1. So always f row f inverse of x is x, f inverse row f of y is y. So here in the second one, same story, but here the difference between the one up and the down, here I have domain to 5. So first of all, this is monotonic. Check it by yourself. Okay, so you can check it by yourself. So here we replace x by y and y by x. So you're going to get 2y equal 7 minus x plus 7, and this is the inverse function. Now the domain here for the function f is x belong to and 5. I need to find the domain of the inverse function. How do I find the domain of the inverse function? We said x will be y, y will be x. So I need to find the range here, the y, the codomain, the y will be x. So for that reason, I replace x by 2. What do I get? F of 2 equal minus 4 plus 7. 3. Here at 2 it's a close, it's better to put a close not to make a mistake. F of 5 is minus 10 plus 7 is minus 3. Here it's open, so I put it as open. So for f of x, the domain is from 2 till 5. So the range will be from minus 3 open, here you can see from least to biggest, till 3 closed. So for f inverse of x, domain will be here minus 3, 3, because you permute y to x, and the domain here will be the range, so 2 till 5. Let us check it using the GeoGebra here. Let me put new. You can see it. So the first one, the function that I have, y equal f of x equal minus 2x plus 7. So this function I want it from function f, start value I have it, I want it from 2 till 5, 2 till 5, start value 2 till 5, so I'm going to delete this one, I have the red one alone. With the inverse we found it to be minus x plus 7 over 2, minus x plus 7 over 2, minus x minus, let me check, minus x plus 7 over 2, so the minus is inside, minus x plus 7 divided by 2, and the domain here, function, so I have function a, starting value, I think from minus 3 till 3, minus 3 till 3, and if I want to delete the function, as you can see, and if you graph y equal to x, so you can see are both symmetric. If you pick a point here and you do the symmetry, you can see that, and you join it by a segment, you can check it, that both are symmetric with respect to that line, which is y equal to x. So another example, suppose I want to find the inverse of this one. So first of all, and it's on 0, 3 closed. So f of a equal f of b to check if monotonic. So minus 3a minus 5 over a minus 2 equal minus 3b minus 5 over b minus 2. I do cross multiply. Okay, but after doing cross multiply, you can cancel 10 and 10, ab and ab here. You bring a to that side. So 11a, b to that side equal 11b. So a equal to b. So the inverse is a function since it is monotonic. So we do now the domain and the codomain of f. So f of 0, it's minus 5 over minus 2. Sorry, this is 2.5. By mistake, I'm very sorry. And f of 3, it's minus 9 minus 5 minus 14 over 1, so minus 14. So here it will be, as you can see, both are close. So here a close, so here a close. So the domain will be from minus 14 till 2.5, the codomain, the range of y. So for the inverse function, x will be y and y will be x. So it will be from minus 14 till 2.5, the domain of the inverse function. Now we need to find the inverse function. We replace y by x and x by y. We do cross multiply xy minus 2x equal minus 3y minus 5. Because I want to solve for y, I put y on one side and everything to the other side. So I bring this 2x to the other side. So you're going to get xy plus 3y equal to x minus 5. Because I want to solve for y, I put y in factor. So x plus 3 equal to x minus 5. And this is the inverse function that we found. And this is its domain. And this is its range. As we saw in GeoGebra, no need to do it for each one. You can do it by yourself. Here also I want to check if it's monotonic. F of a equal f of b. So root a minus 5 minus 3 equal root b. So I can cancel here these 3. So I square both sides now. All sides I square it. I'm going to get a minus 5 equal b minus 5. Cancel here the 5. So it's a equal to b. So the inverse is a function. Now I want to find the range of the f, which is the domain of the inverse. I do f of 6. So it's 1 minus 3 It's minus 2, f of 9, so root 4 is 2, 2 minus 3 is minus 1. Here at 6, it's open, here at closed. So for f of x, this is the domain, and the range will be from minus 1, from minus 2 open till minus 1 close. And for the inverse function, x will be range and y will be x, which is the domain. Now I need to find the inverse function. I replace y by x and x by y. Now I put y on one side, but it's a square root. I put the whole square root on one side. I take the minus 3 to the other side. Okay, so I square both sides now. So x plus 3 square equal y minus 5. And to find y, I take 5 to the other side. This will be the inverse function. And this is its domain, minus 2 till minus 1. Here, it's a power 3. So I want to check if monotonic. So minus a cube plus 2 equal minus b cube plus 2. 2 and 2 cancel. So a cube equal b cube. So a equal to b. So the inverse is a function. So f of 0 is 2. F of 1 is 1. Open here, here close. So the domain is for f of x 0, 1. And the range will be from 1 till 2. So for f inverse of x, the domain will be just the inverse. So it will be from 1 open till 2 close, and the range will be from 0 till 1. And to find the inverse, I replace y by x and x by y. I will get x equal minus y cube plus 2. I put y on that side and x take it to the other side. So because I have a cube, so to remove the cube, I put cubic root of 2 minus x, which is the inverse functions. Now for some exponential and logarithm, note first of all, if y equal a power x, a is a number and the variable here is up. If you want to find x, x equal log base of a of y. Sorry for this mistake. X equal log base a of the answer. So here this number here will be the base where you have the power, and the answer will be inside the log. So here I want to solve this one. First of all, I want to check if monotonic. So if f of a equal f of b, so 3 into 2 power a minus 1 minus 5 equal that of b, as you can see here. 5 and 5 cancel. Then divide both sides by 3. So 2 powers are equal if the powers are equal because they have the same base. So a minus 1 equal b minus 1, so a equal to b. So I need to find the f of 1, so replace by 1. 2 power 0 and 1 minus 1 is 0, is 1. So 3 minus 5 is minus 2. And if you replace by 3, 3 minus 2, 1 is 2, 2 square is 4, 12 minus 5 is 7, here close, here open. So this is the domain. The range will be from minus 2 till 7. And for inverse, just as we did above, we switch. Now I want to find the inverse. I replace y by x and x by y. So I put here, I want to apply this property, the power to that alone. So I take the plus minus 5 to the other side plus 5. I divide it by the coefficient here over 3. So I start by the power. So I write the power equal log base of what? Of this number, as we said. Log base 2 of the answer. So the answer will be where? Inside, and I take minus 1 to the other side. This will be the inverse function for the logarithm. Sorry, he can same mistake because always I do is copy and paste. So here a, here y, and something else I want you to know. If log base a of x equal log base a of y, so you have the same base. So x equal to y. So we're going to check monotonic. Suppose f of a equal f of b. So 2 log base 3 of 2a minus 3 plus 5 equal 2 log base 3 of 2b minus 3. So 5 and 5 cancel out. Divide both sides by 2. As we said before, if 2 are equal, they have the same base. So x is y. So in that case, 2a minus 3 equal 2b minus 3. So a will be b. So the inverse is a function. Now I do f of 2. So you can use your calculator. You have the log in the calculator. You're going to get 5. If you replace here by 3, as I said, use your calculator, you're going to get 7. So this is the domain, this is the range, and vice versa for the inverse function. Now I replace y by x and x by y. I put logarithm on one side, I take this to the other side. Always here, if you have this one, you start from inside. Inside is what? 2x minus 3. Okay, inside I have 2x minus 3 equal, this is what I have the power. The power is the log base a. Here, so 3. 3 power what? The answer. So always inside when you have log equal 3 power the answer. So I want to solve for x. I take minus 3 to the other side, then I divide it by 2. Now I want to take the examples of an equation of second degree. You all know that equation of second degree, it's a parabola, it's not one-to-one. You know, if you take, for example, f of x equal x power 2, for example, here, not one-to-one. What we are going to do, we're going to split it into two parts. We're going to search for the vertex, like here in this example, 0, 0. We're going to take to the right of 0, and we do its inverse alone, to the left of 0, and do its inverse alone. Okay, so our aim when we have an equation of second degree, because it's not one-to-one, we're going to find the vertex. We're going to split the domain into two parts, to the right of the vertex, because in that case it will be monotonic, and to the left of the vertex, because it will be monotonic. So here we're going to find the appropriate domain and find the inverse. So I have an equation of second degree. You have from minus 2 till 2. So let me do it first of all on GeoGebra to understand well what I mean. So here you have, for example, the first one, you have 2x squared minus 4x minus 1. So this is the parabola that I have. And the vertex here, extremum in GeoGebra of polynomial f, as you can see here, and the domain that they gave me is from minus 2 till 2. So function, I have function f from minus 2 till 2. So as you can see here in this function, that this is the given. So I cannot take, so from minus 2 till 2, so till 15 the range. So as you can see here, I cannot, I must take this alone and that alone. So this domain that I have from minus 2 till 2, I must split it from minus 2 till 1 alone, and from 1 till 2 alone, because from minus 2 till 1, it is strictly decreasing 1 to 1 and on 2, and from 1 till 2 is also. So let us go and check. First of all, I find the vertex. The vertex, as you all know, is minus b over 2a. So it's 4 over 4 is 1. So this domain, which was from minus 2 till 2, here minus 2, here 2, I have 1 between. Because this is the vertex and it had that 4, the curve, I take from minus 2 till 1 alone, because it will be decreasing, monotonic, and then from 1 till 2. So I split it into 2. So each one has an inverse. This one I want to find its inverse, and that one I want to find its inverse. Okay, so I have two inverses I need to find for this one and for that one. So I do the images first of all. F of minus 2, if you replace it here, you're going to get 15, as we saw in the picture. F of 1, the vertex, you're going to get minus 3. And F of 2, we're going to get minus 1. Here, the vertex, if inside, close it on both because it's included. So for the first one, minus 2 till 1 in F of x, this will be the range. I know minus 2 is 15, 1 is minus 3. And from 1 till 2, the y will be, the range will be from minus 3 till minus 1. So this is for f of x. Now I want to find the inverse. I replace y by x and x by y. So this is an equation of second degree in y. So I bring x to that side. So 2y squared minus 4y minus 1 minus x is 0. So coefficient of y squared is a is 2. Coefficient of y power 1 is minus 4. And the rest is what? 1 minus x, because these are coefficient y power 0. So I do delta b squared 16 minus 4, 2 times minus 1 minus x. If you do the This one you can put foreign factor. This is delta. This delta is positive. Why this delta positive? Always positive. If you replace from -2 till 1, it's positive, or from 1 till 2 is also positive. So I have two roots, y prime and y double prime. These are the two different inverse. It's minus b, so 4, plus radical delta. Radical 4 is 2, radical 6 plus 2x over 4. And 1 plus 1 minus. Now we switch 4 over 4. What do you get? Always you get here. The one here, you're going to get the vertex. You're going to get it here. It will be 1 plus root 6 plus 2x over 2. And the other one, 1 minus root 6 plus 2x over 2. How do we know the domain of each one? Here it's bigger than 1. To the left, to the right, sorry, from 1 till 2. From 1 till 2, it will be which one? This one. Okay, this is to the right, and 1 plus, so 1 more than 1. So this will be the domain, this will be the range. Here will be 1 minus from that side, less than 1. Less than 1, it's from -2 till 1. This will be its domain, and this will be its range. So if you want to check it on GeoGebra, we can. So let me graph a of x equal 4, parentheses first, 4 plus 2 times star square root, you put sqrt, parentheses 6 plus 2x, the whole thing you divided by 4, divided by 4. So, and the second one, and you have function, let me say function from function a, as we said, start value from the first one, -3 till -1, -3 till -1. Okay, so let me get rid of this first one. So this inverse of that one, and if you do, let me do for one. You can do it for if for the rest. It's the same. So if you pick here a point, and here, if you pick a point here, sorry. If you pick a point here on this one, and you do the symmetry with respect to y equal to x, you're going to get opposite. If you join it and you do some animation, you're going to check and know it is anyway. You can check also for the second one. If you do for that one, you put the other one, you can get, for example, let me do for the other one. Instead of putting a plus, I'm going to put, because it's the same, minus. Okay. But the difference is the range here. You have it for the second one from -3 till 15. From -3 till 15. You can see. So this is the inverse of that one. If you pick a point here and you do the symmetry with respect to this one, symmetry with respect to that line, and if you join it and you do animation, you're going to see that I split it into two parts. Okay, so here when you have second degree, so when you have second degree, you need to find the vertex. If the vertex is between, between the two, you split it into two interval and you work on each interval alone. So to finish from this one, let me take the last example. Here I have also an equation of second degree. I want from 3 till 4. I find first of all the vertex. The vertex is 1. As you can see, 1 is not between 3 and 4. So since 1 is not between 3 and 4, so it's outside. So I have a part where it's monotonic. So directly it's monotonic. I'm going to see it on GeoGebra now. It's monotonic, so no need. So here you have f of x equal minus x squared plus 2x plus 5. So I want, and the vertex extremum here, as you can see, of the polynomial f, this is the extremum. I want function domain is given f from 3 till 4, I think, yes, from 3 till 4, from 3 till 4, 3 till 4. As you can see here, since, so it's, because it's to the right of the vertex, it's monotonic, strictly decreasing, so the inverse is a function, so no need to split into interval. Just I have this only interval. So I do f of 3, I replace, as we did before, f of 4. This is all you all know. You switch it x to y and y to x. You replace y by x and x by y. You take x to the other side. So you have y square, or this to that side, not to get a negative. Y square minus 2y minus 5 plus x is 0. A is 1, b is minus 2, c is minus 5 plus x, the rest. You do delta b square 4 minus 4ac. You can check by yourself. So always it must start by, here you must start by vertex is minus b over 2a. So if you do minus b, so this will be 2. Always you must have here, what is the number here? You have 1, you must have here what? 1. So this is 1. Only the number you have it here, you must have it here. So minus b is 2 plus radical here 2, radical 6 minus x over 2a, which is 2. So you split 2 over 2 is 1 plus radical 6 minus x, and this is its domain. I hope that you got this lesson. This is the longest video I made because I learned, you have learned how to use the GeoGebra, and this will, it took us some time. I hope that everything was clear, and see you in class.